Okay, in this chapter we will see the different types of refrigerant and their color code and their properties. So as you know that refrigerant is a fluid which circulates in refrigerator. Refrigerant is a substance or fluid that picks heat from evaporating coil and it passes through the compressor where its temperature and pressure rises by the compressor, and then it goes to the condenser, and at the condenser it again condenses in liquid form and again come back to the expansion valve and then evaporator, and these cycles continues. So it's the refrigerant changes its phases. Now let's see the desired characteristics of refrigerant. Okay, so refrigerant must be volatile or capable of being evaporated. Okay, this is a most important thing, that refrigerant must be volatile. That is volatile means its tendency to vaporize, by small amount of it should vaporize, and the latent heat of vaporization of the refrigerant should be high. Okay, refrigerant should not burn or support combustion or be explosive. Refrigerant should be harmless to the pupil and should have odor that will make its presence known. If there is leakage, then if there is a particular odor, then the pupil will know that there is a leakage. So leaks should be detectable by simple tests. Okay, cost of the refrigerant should be reasonable and it should be available in sufficient quantities for commercial use. Refrigerant should be stable, have no tendency to break down. It should have no harmful effect on metals. Okay, so these are the desirable characteristics of refrigerant. Now let's discuss the flammability and toxicity of refrigerant. Okay, the flammability is a property of mixture in which the flame is capable of self-propagating for a certain distance. Okay, generally speaking, flammability of refrigerant is its ability to burn or ignite, causing the fire or combustion. Let's see the lower flammability limit. The flammability limit is two types: upper flammability and lower flammability limit. So it is the minimum concentration of the refrigerant which causes the combustion. So combustion or explosion. So it is at a test condition 23 degrees Celsius and 101.3 kilopascal. So for methane gas, the lower flammability limit is around 4.4%. Okay, so it means that if the atmosphere has less than 4.4% methane, combustion cannot occur even if a source of ignition is present. Okay, if the concentration of methane is more than 4.4%, then only there will be chances of combustion in the presence of external ignition sources. So this is the lower flammability limit below which refrigerant cannot ignite. And let's see the upper flammability limit. Upper flammability limit is the highest concentration of the refrigerant. After that it cannot combust itself in spite of even if there is a presence of external arc, flame, anything. So if the mixture is too rich, it is also not possible to combust the refrigerant. So refrigerants are divided into three groups according to flammability. You can see that class 1, class 2, class 3. These are the three groups which divide the refrigerant. So class 1 indicates that do not show flame propagation when tested in air at 21 degrees Celsius and 101 kilopascal. So these type of refrigerants are the best type of refrigerant which do not indicate any type of flame propagation when tested under 101 kilopascal and 21 degrees Celsius. Even if you have external ignition source, then it is not showing any flame propagation. But in the class 2 type of refrigerant, you can see that when it is tested under 21 degrees Celsius and 101 kilopascal, there is a chances of heat combustion of less than 19 kilojoule per kg. Okay, 19 kilojoule, heat combustion of 19 kilojoule per kg is there. So it is class 2 type of refrigerant. And class 3 refrigerant, this refrigerant is when tested under 101 kilopascal, 21 degrees Celsius, it shows the heat of combustion greater than or equal to 19 kilojoule per kg. So this lower flammability limit and upper flammability limit defines the flammable range of the refrigerant, and this is a described by the American Society of Heating, Refrigeration and Air Conditioning, ASHRAE. Remember this full form of this ASHRAE, American Society of Heating, Refrigeration, Air Conditioning Engineers. Now let's see the toxicity of refrigerant. So this is very most important part. We do not want any toxicity in our refrigerant, because if there is a leakage of refrigerant, that may cause the serious problem to the persons, and many people may affect with this. So these are the refrigerant which are classified in two groups. This is a class A. This class A, there is no evidence of toxicity when the concentration is less than or equal to 400 ppm. Okay, these are the class A. So we desire class A type of refrigerant. And class B, this says that if there is a concentration below 400 ppm, then there is chances of toxicity in the refrigerant, signifies refrigerant for which there is evidence of toxicity at concentration below 400 ppm. So in this case there is evidence of toxicity, so it is divided as class B, which are toxic, and class A, which are non-toxic. So here we have a chart. You can see that A series are located by the lower toxicity and B are higher toxic. So this is B1, these are non-flammable, and A12, B12, these are has a lower flammability, and A2, B2 is flammable, and A3, B3 is high flammability. These has high flammability. So remember this, A1 is R134A, which is the best refrigerant since it has lower toxicity and it is also non-flammable. So it is one of the best, you can say. And B2L has lower flammability and it is a toxic too. So this is ammonia. And A2, this is R152A. A3 is hydrocarbon. Now let's see the important properties of different refrigerant. This is a R11, which is a trichlorofluoromethane. R12, dichloro-difluoromethane. Monochloro. R22 is a monochloro-difluoromethane. R717 is ammonia. R502. So this is R502 is basically R22 plus R115. Now the most important part is their boiling point. See, R11 has boiling point of 23.8 degrees centigrade. This is, I think this is a minus 23.8 degrees Celsius. R12 has minus 29.8 degrees Celsius, and R22 has 40.8 degrees Celsius, and R717, that is ammonia, has minus 33.3 degrees Celsius, and R502 has minus 45.6 degrees Celsius. So these are also their properties: critical pressure, critical temperature, and remember the critical temperature of this only 133 or 132 around the critical temperature of this ammonia. And leak detection is done by a light torch to the R1112 or R22, but you can't use halide torch for detection of ammonia because it is toxic in nature. So SOT gas is used to detect the leakage, which gives the white smoke. Okay, and inflammable, this ammonia is only inflammable. So now let's see the color code of refrigerant cylinders. See, this R11 is orange, R12 is white, R22 is green, R502 is orchid. Orchid means bright purple. R717 has silver, which is ammonia. Ammonia has silver color. And R134 has light blue. This is not white, this is light blue. So remember this color code. This may be important from the exam point of view. Okay, now next is refrigerant and their effect on ozone. As you know that the CFC are very harmful for the ozone layer because chlorofluorocarbon, which contains chlorine, react with ozone and changes it to oxygen. So freons or chlorofluorocarbons are very harmful, and that destroys 1000 times greater than carbon dioxide. So you can see that there are ozone depleting potential of different refrigerants. So we will see the basics. CFC 11 has R11 has 1 ODP. This is also called ODP, ozone depleting potential. R22 has 1, and you have to remember some few only. This is HCFC 22, which has 0.055. This Montreal Protocol, this is a treaty among the country to restrict the use of chlorofluorocarbon since it depletes the ozone layer. So it was a summit. It was a treaty which was held in 1987. So remember, this is related to ozone depletion, Montreal Protocol. And there is a Kyoto Protocol which is related to global warming, greenhouse gases, which was held in 1997 in Japan. So this is related to global warming. CFC gases are refrigerants are harmful for the environment, so it is replaced by hydrocarbons, hydrogenated hydrofluorocarbons, which are less harmful for the environment, for ozone. Basically, hydrocarbons are environmentally friendly, and in many cost for electricity consumption it will lower. The only limitation of this hydrocarbons is that it is flammable. So only its limit is to domestic refrigerator. So this table shows that these CFCs are replaced by this HFC. R12, it is replaced by R134A, which are used in domestic refrigerator, freezers, commercial appliances, small size, medium, high temperature refrigeration and air conditioning system, centrifugal air conditioning system. And this R502 is replaced by R404A. R22 is replaced by R407C. Okay, so remember this thing that R12 is replaced by R134A, R502 is replaced by R404A, R22 is replaced by R407C. HFCs like R134 is generally inflammable in normal temperature and pressure condition, but when the certain condition like 0.4 bar and 177 degrees Celsius, when its concentration is greater than 60%, Okay, now the leak detector. Soapy water can be used to find the HFC leaks. Soapy water is good, safe, accurate method of leak detection. A halide torch must not be used to detect the HFC leaks as toxic fumes will be produced. So it should be remembered that HFC, if there is leakage of HFC, then halide torch cannot be used to detect the leakages. Okay, now let's see some of the questions related to this topic. Question number 5 is which one of the following refrigerant is toxic? R11, R12, R22, R717. Since we have seen that the R717 is ammonia, which is very toxic in nature, so option D is correct. Which one of the following refrigerant has the lowest boiling point? We have seen the boiling point of different refrigerant. R11 has 23.8 minus 23.8 degrees Celsius, R12 has minus 29, and R22 has 40 point something, and R717, which is ammonia, has minus 33.33. so R22 has the lowest boiling point, which is minus 40.8 degrees Celsius, so option C is correct. Which one of the following refrigerant has the lowest relative ozone destruction efficiency? So we have discussed the chart of different refrigerants, so where we found that this R22 has the lowest ozone depletion potential, which is around 0.055, so option C is correct. Okay, question number 8. Which of the following property is desirable in refrigerant? Low boiling point, high critical temperature, high latent heat of vaporization, all of the above. So it is all of option D, which is all of the above. Since in good refrigerant we require low boiling point so that it can vaporize easily, high critical temperature, high latent heat of vaporization. So it do not we ensure that it do not vaporize in liquid line, so it should have high latent heat of vaporization. Next is a good refrigerant should have high melting point, medium melting point, low melting point, or any melting point. So option C is correct, it should have low melting point. Next is secondary refrigerant is useful because it is cheap, it helps achieve low temperature, it helps produce primary refrigerant piping. D, none of the above. So option C is correct, it helps reduce primary refrigerant piping. Secondary refrigerants are water, air, these are the secondary refrigerants, and freons or HFCs are the primary refrigerants. So option C is correct, it helps reduce primary refrigerant piping. Next we see that the leakage in refrigeration system using freon is detected by, for freon it can be detected by halide torch. We can't use for FCs, we can't use for HFCs halide torch as leakage detector. We can use CFC for the case of CFC halide torch, and in case of HFCs we have to use soap water. Next is when a little quantity of moisture in combination with freon can form, the moisture can form with freon hydrochloric acid, so option D is correct. Okay, one of the desirable properties of refrigerant is that it should have low specific heat. Okay, so option D is correct, low specific heat. Okay, thank you, thanks for watching. Please subscribe my channel and like, share, comment on my videos.